All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria covnets module. Let's have a look at what we went over today. Now, yesterday, if you recall, we went over the process of counting our or using our input and our filter to determine how many output features we would have. And today, we're going to pick up where we left off. So note, if we add pattern to our input will increase by twice the number of our specified pattern size. For example, if we have an output or if we have an input size of 7 by 7 and we add padding of 1, we would now have an input the size of 9 by 9. This is because 1 is added all the way around. 1 to the left, 1 to the right, 1 to the top, 1 to the bottom. And if you do the math, if you add 1 to the left and 1 to the right, that'll give us a 9 by 9 instead of 7 by 7. If you have 1 to the top, 1 to the bottom, that would give us a 9 by 9 instead of a 7 by 7. Note, this will also increase our output size as well. This is because we have more input space to travel through with our kernel/filter. Now that is a basic understanding of how a pattern works. We generally use the zero pattern, though there are other pattern methods, but the zero pattern is one of the most common since it's easy to use and is computationally less expensive to work with. And we also have another advantage of working with a pattern, which is that of ensuring that the corner pixels have an influence on our output features which are generated. Let's imagine that we stay with zero pattern for now. If we're dealing with an image in which most of the information or most of the relevant information is centered, then there is actually no issue since the kernel or filter will go through each and every pixel we have of our image of a person. Now, if we modify the image such that we have a person's face at the corner of the image, that'll change things up. So you have to imagine that we have, let's go back to the top and look at our original. So let's say we have an image here of a person. It wouldn't be a problem for our filter to go through every pixel of this image here because it's centered. So the filter can pass directly through. But on the other hand, if we have an image of a person's face here in the corner, we wouldn't be able to pass through every pixel because it's here in the corner, and our filter wouldn't be able to go through because it's limited by the size of our input. So it can't pass through because it can't go outside of the input. So it only could pick up certain or specific coordinates of the face if it was in a corner. So that's what that means there. We'll see that unlike with the image where the person was centered and that our kernel filter was able to pass through each and every part of the image, with the image of the face in the corner, we have a different scenario. It's the one I just explained to you. Now, what we could do is if we monitor the number of times the kernel filter goes through the center person's head, we would see that we can actually count the number of times the kernel or filter passes through easily. But in the case of the image of the face in the corner, we are on the borders of the input, and since we are on the borders, move down some, we cannot successfully pass our kernel filter through the entire image of the face because the kernel filter cannot go outside of the input's grid to pass through, like I just explained. Now that's just the gist of what we went over this morning. We did a lot more of that and went into detail a lot more. I did take a lot more notes to get a lot more understanding. And I'm going to leave it there for now because I don't want to do a bunch of reading this morning. But yeah, we will pick it back up tomorrow. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.